Hi guys, now we are going to solve this nice olympiad problem. If x belongs to set of all real numbers, then we have to find the real solutions for the problem. X plus 2 is equal whole to the power 4 plus x plus 1 whole to the power 4 is equal to 17. Now we just take x plus 2 is equal to A and x plus 1 is equal to B. Then that is A is equal to x plus 2 and B is equal to x plus 1. Then our problem becomes A to the power 4 plus B to the power 4 is equal to 17. But you know that the formula regarding A to the power 4 plus B to the power 4 plus A plus B whole to the power 4 is equal to 2 times A squared plus AB plus B squared the whole squared. Now we need to apply this formula here to get the real solutions. Okay, so here what is our original problem? X plus 2 whole to the power 4 plus x plus 1 whole to the power 4 is equal to 17. Compare this formula with this result. Here we have 3 terms, but here we have only 2 terms is present. So we need 3 terms. For that you just add 1 on both sides of this equation. So 1 plus x plus 1 whole to the power 4 plus x plus 2 whole to the power 4 is equal to 1 plus 17. Or you can take another assumption, t is equal to x plus 1. Okay, so we have to substitute x plus 1 is equal to t here. So 1 plus t to the power 4 plus, but here x plus 2 is there, so you can write x plus 1 plus 1. Okay, and x plus 1 is t and plus 1 you have to write it. So x plus 2 whole to the power 4 in terms of t can be written as t plus 1 whole to the power 4 is equal to 1 plus 17 is 18. Here compare this formula with this equation. So here in the place of a to the power 4, we can write this to be 1 to the power 4. Plus in the place of b, we have a t, and a plus b is t plus 1 whole to the power 4 is equal to this. Some constant is there. So here, instead of this, you can write this 2 times a squared plus ab plus b squared the whole squared. And a is equal to 1 here and b is equal to t. So substituting here 2 times 1 squared plus 1 times t plus t squared, the whole squared is equal to this 18. You have to write it. Or you have 1 squared is 1 plus t squared, the whole squared is equal to 18 over 2. This 2 is taken to the right hand side. So we have t squared plus t plus 1, the whole squared is equal to 9. Isn't it? That is 9 times 2 is 18. So this value is equal to 9. Now we had to take square root on both sides. So you have t squared plus t plus 1 is equal to plus or minus square root of 9 is 3. Okay, when you're taking square root, the square root and square get cancelled, and here we have two possible values for 3, plus 3 and minus 3. So from this you can write two equations you have. One is t squared plus t plus 1 is equal to 3, and t squared plus t plus 1 is equal to minus 3. So we have two possible equations. So from this you have t squared plus t plus 1 minus 3 is equal to 0, and from this you have a t squared plus t plus 1 plus 3 is equal to 0. So here we have t squared plus t, okay, 1 minus 3 is minus 2 is equal to 0, and another one is t squared plus t plus 1 is 4 is equal to. So we had to find out the real solutions from these two equations. The equations are t squared plus t minus 2 is equal to 0, and t squared plus t plus 4 is equal to 0. So here, according to our problem, we have to find out a real solution since x belongs to R, and we take t is equal to x plus 1. So t is also belongs to set of real numbers. So we have to find out the real solutions. For that, we have to find out b square minus 4ac value. So here a is equal to 1, b is equal to 1, c is equal to minus 2 here. So b squared is, b value here is 1. So 1 squared minus 4 times 1 times c is minus 2, which is 1. 4 times 2 is 8. 1 plus 8, which is equal to 9, which is positive. So this is positive. So we have two solutions for this problem. So this value is positive. So we have two real solutions. Two real solutions for this problem. Okay, so we can conclude that two real solutions. We have to find out those real solutions. So here we have a t squared plus t minus 2 is equal to 0. When you multiplying two numbers, you get minus 2. We have to find out the roots for this problem. So when you multiplying two numbers, you get minus 2. And when you adding two numbers, you get plus 1. So which is possible? 1 times 2 is 2. But we need minus 2 and here plus 1. So this time it is smallest number is negative. Minus 1 times 2 is minus 2 and minus 1 plus 2 is 1. So the roots are directly, you can write it t minus 1 times t plus 2 is equal to 0. So from this t is equal to plus 1 and t is equal to minus 2. But what is t? T is equal to x plus 1. So x plus 1 is equal to 1 and x plus 1 is equal to minus 2. From this, x is equal to 1 minus 1, that is x is equal to 0. So from this we have x is equal to, I'll write it here. So from this we have x is equal to 0, and here from this x is equal to minus 2 minus 1. So from this we have x is equal to minus 3. So we have two solutions, two real solutions for this problem, and here we had to find out whether we get real solution or not. So here also b squared minus 4ac value we had to find it out. So a is equal to 1, b 1, c is 4. So b squared 1 squared minus 4 times a is 1, c is 4. So 1 minus 16, which is negative, less than 0. This is negative. So we get this equation does not have real solutions. That is here no real solutions for this equation. So only complex solution is you can got it. So that's why we omit this, and since x belongs to R, we had to find out the real solutions, and those two solutions are x is equal to 0 and x is equal to minus 3. We just check our answer. Our problem is x plus 2 whole to the power 4 plus x plus 1 whole to the power 4 is equal to 17. So when x is equal to 0, we have 0 plus 2 the whole squared plus 0 plus 1 the whole to the, sorry, here you have whole to the power 4 is equal to 17, and 2 to the power 4 plus 1 to the power 4 is equal to 17. 2 to the power 4 is 16 plus 1 is equal to 17, or 17 is equal to 17. And whereas next solution is when x is equal to minus 3. When x is equal to minus 3, we have, here we have to substitute x is equal to minus 3. So minus 3 plus 2 whole to the power 4 plus minus 3 plus 1 whole to the power 4 is equal to 17. Minus 3 plus 2 is minus 1 whole to the power 4. And here you have minus 3 plus 1 is minus 2 whole to the power 4 is equal to 17. And this is 1 plus and this is 16 is equal to 17. So 17 is equal to 17. So both solutions are correct. So two real solutions for this problem are x is equal to 0.